The last video in the unit is modeling with conic sections part 2. So we'll do 3 more problems here. The lines 4/3 x minus 5/3 and y equals negative 4/3 x minus 13/3 each contain diameters of a circle, and the point negative 5, 0 is also on that circle. Find the equation of this circle. First thing you have to understand is that when you have two diameters, they will intersect at one point, and that one point is the center. Therefore, we would solve the system of equations probably by setting these two equal to each other. So 4/3 x minus 5/3 equals negative 4/3 x minus 13/3. 8/3 x equals negative 8/3. And that means x equals negative 1. Now when we take x, substitute negative 1 back in for x, we will find out that y equals negative 3. So because y equals negative 3, we have the equation x plus 1 squared plus y plus 3 squared equals r squared. And then our job is to now find y, or I'm sorry, our job is to now find r. Since the point negative 5, 0 is on the circle, negative 5 plus 1 squared plus 0 plus 3 squared equals r squared. Let's continue to solve. So negative 4 squared plus 3 squared equals r squared. We should know that that's a 3, 4, 5. If we were in the Pythagorean theorem mode, we would know that that's a 3, 4, 5. So r is equal to 5. And therefore, our final equation, and since all it asks for is the equation, we don't have to graph or anything, our equation is x plus 1 squared plus y plus 3 squared equals 25. That's problem 4. Problem 5. Pizza delivery area can be represented by a circle that extends to the points 0, 18 and negative 6, 8. Those points just so happen to be on the diameter of this circle. Since we know two endpoints of the diameter, we can find the midpoint. The midpoint is negative 3, 13. What we need to do now is write the equation of the circle that models this delivery area, since we found the midpoint. And if you need to know how to find a midpoint, you add up the x values, divide by 2, add up the y values, divide by 2. We will then write the equation of this circle. And our objective is to now find what the radius squared is. So we will take one of the points and substitute it in. I'll take 0, 18 and substitute it in. So we get 3 squared plus 18 minus 13 is 5 squared. So this is going to equal 34. So the radius is the square root of 34. And r squared is 34. So x plus 3 squared plus y minus 13 squared equals 34 is the equation of our circle. Last problem, problem 6 on your worksheet. For some reason, the 6 disappeared when it was copied over to the Smart Notes. An architect's design for a building includes some large pillars with cross sections in the shape of hyperbolas. The curves can be modeled by the equation x squared over 1/4 minus y squared over 9 equals 1. Units are in meters. If the pillars are 4 meters tall, find the width of the top of each pillar and the width of each pillar at its narrowest point in the middle. So if we want to graph this, I could graph just right on the pillar, but I don't. I think it's too colorful for what we're doing right now, so I want to just kind of separate it. What we have is we have x squared over 1/2 squared minus y squared over 3 squared equals 1. So that means if I'm making my my box that I usually make, in order to make a hyperbola. Oops. I need to kind of make a designation for 1/2. I should probably use a different color for that so we don't get confused. So 1/2 on the x, 1/2 and negative 1/2. So I'm going to make my box that extends up to y equals 3 and down to y equals negative 3, since the center of our hyperbola is at 0, 0. I have the vertices at 1/2, 0, and negative 1/2, 0. And then if I draw the asymptotes, I can get a pretty decent picture of what the hyperbola looks like. Now remember, what's really happening here is the hyperbola doesn't extend forever. The hyperbola only goes 4 meters. So because the hyperbola only goes 4 meters, I can stop at y equals 2. So this pillar is really modeled by what's going on between the green lines. So that's the model for my pillar. So what I need to do here is I need to figure out this distance, because it asks for the distance, the width of each pillar at the narrowest point in the middle. Well, since I had, yellow's a bad choice there. Since I had 1/2, 0, and negative 1/2, 0, that distance is pretty simple. It's 1. So the distance, or the width, at the narrowest point is 1 meter. Now, what about at the widest point at the top? Well, at the widest point at the top, those points are, well, the y value is 2. So I need to find out what that x value is. I could also have done at the bottom, I could have done negative 2, because it would be the same value since the center's at 0, 0. But I'm choosing to use the positive one just for the sake of ease. So now my job is to take, I'm going to take 2, I'm going to substitute that in for y, and then we'll figure out where to go from there. So x squared over 1/2 squared, or 0.25, or 1/4, minus 2 squared over 3 squared equals 1. Well, 2 squared over 3 squared is equal to 4/9. So I'll add 4/9 over. I have x squared over 0.25 equals 13/9. If I multiply both sides by 0.25, that's the same thing as multiplying both sides by 1/4. So I have x squared equals 13 over 36. Then I take the square root of both sides. I get x equals plus or minus the square root of 13 over 6. That is approximately plus or minus. We'll just take the positive case and deal with this point up here. But that x value is positive 0.6009 or so about 0.601. So that would be approximately what it is if you type it in the calculator. Now, our job is to find the width at the highest point. So that means we're going from root 13 over 6 all the way over to the other side, which is negative root 13 over 6 for the x values. So that is a distance that's twice as far as root 13 over 6 is from the y-axis, which means, I'm sorry, yeah, the y-axis. So that means that the widest distance is root 13 over 3, which is approximately 1.202 meters. So that would be how you do that problem. And I hope you have enjoyed your foray into conics this chapter, and ask your teachers any questions if you have any.